Okay guys, 8b.4, we're actually going to be solving log equations. So for the log equations, to solve them, I'm going to put x in different spots in the log, and we're just going to use our what we know about logs and what we know about the rules of exponents to solve for x wherever it is. Just as a note, some of the problems will have no solution because whatever we end up with will not be possible. Okay, so it is possible to get no solution on these. So let's look at examples 1 and 2. Okay, so example 1. I have log base 3 of x equals 4. So this time x is what we're taking the log of. So to solve this, we're going to go through the logs. So this is going to be 3 to the 4th equals x. Now, can we do 3 to the 4th, guys? Yeah, what is it? 81. So x equals 81. So, guys, what did you do first? So this is the same as what? 2 to the 5th equals x. And what does 2 to the 5th equal? 32. Good. Okay. Piece of cake. Let's look at number 3. Log base 3 of negative 3 equals x. So if I was going to solve this, I'm going to go up and around. So that's 3 to the x equals negative 3. What exponent could I plug in to x that would change my base of positive 3 to a negative 3? Would negative 1 change it? Negative 1 would make it a 1/3. So is there anything? No. So this is no solution. Because even if we were to plug in 0 for x, 3 to the 0 gives me what? 1. So it's never going to be negative. Okay, so do number 4. Okay, guys, so this is log base 2 of 2 equals x is the same as 2 to the what? 2 to the x equals 2. And if I have just a 2 by itself, what's actually the exponent? A 1. So in this case, x equals what? 1. Does anybody recognize that this was a special case? Yeah, so this is the same as 2 to the 1st power. So my bases are going to drop anyway, so my x will come out to the exponent, which is 1. Okay, you could have done that either way. Okay, so far so good? Okay, 5 and 6. Log base x of 64 equals 2. So in this case, my variable is in the base. So this is going to be the same as x squared equals 64. And what would I do to get x by itself? Square root it. So that's going to give me x equals what? 8. Now, in the past, whenever we were the ones making the square root to solve, what did our answer have to be? Plus or minus 8. But at the very beginning of the unit, I gave you kind of a condition that said that the base had to be what? Positive. You cannot have a negative base. So in this case, even though we're using square roots to solve, we can't use the negative 8 because it's in the base of our log. Does that make sense? So your base must always be positive. It can be a fraction, like in number 6. It's okay to have a fraction, but it has to be a positive number, and it also cannot be what? Does anybody remember? 0 or 1. Okay? All right, so it has to be positive, not 0 or not 1. Okay? All right, so let's look at number 6. What would you guys do on this one? This is going to be 1 over 25 to the what power? To the negative 1/2 equals x. Okay, what does a negative exponent mean? Guys, what does a negative exponent mean? You take the reciprocal, right? But my exponent otherwise stays the same. So after you take the reciprocal of the base, your exponent becomes positive, but it stays the same. So this is going to give me 25 to the 1/2 equals x. Okay? That 1/2 does not become a 2. It stays as a 1/2. The only difference is that now it's positive. And what's 25 to the 1/2? 5. Because a 1/2 exponent is the same as what kind of root? A square root. Okay. Number 7, we have log base 3 of 0 equals x. How would I rewrite this as an exponent? Good. 3 to the x equals 0. What exponent could I plug in that would turn my 3 into a 0? Okay, if I were to plug in 0, what would I actually get? A 1. Is it possible to get 0? No. So no solution. Remember, anything to the 0 power is 1. This should make sense, guys, because an exponential function never crosses the x-axis. So it can't be 0, because that would mean we're touching the x-axis. Okay. Number 8, log base x of 4 equals -1. What would you do first? X to the -1 equals 4. Now I have a exponent here that I need to get rid of. What would I do to get rid of an exponent? The reciprocal. So we multiply both sides by the reciprocal. What's the reciprocal of -1? If I multiply both sides by +1, -1 times +1 gives me what? Still a -1. So what would I multiply by? -1. Remember, reciprocal means that you flip the fraction, but the signs don't change. So the reciprocal of -1 is -1. And we can tell because -1 times -1 is what gives me +1, so we have just an x. And what's 4 to the -1? 1/4. So x equals 1/4. Okay, number 9. Log base 5 of 25 square root 5 is equal to x. Let's rewrite it first. So that's going to be 5 to the x equals. Okay, let's rewrite these as exponents. 25 is 5 to the what? 5 to the 2nd, and leave yourselves a little bit of room, times root 5 is 5 to the what? 1/2. Okay, so when I'm multiplying these two things, what do I end up doing with the exponent? Adding them. But can I add 2 and 1/2? No, because this is a 2 over 1. What would my 2 over 1 change to if I wanted a denominator of 2? 4 over 2. So I cross it out and rewrite it as 4 over 2. This should make sense, right? Because 4 over 2 reduces to, what's 4 divided by 2? 2. So 4 over 2 is the same as 2 over 1 because it reduces down. But the reason we do this is because now I can add 4 over 2 plus 1 over 2. What does that give me? 5 over 2. So this is the same as 5 to the x equals 5 to the 5 over 2. And now I can drop my bases. So x equals 5 over 2. Number 10, log base 3 of 27 squared equals x. Rewriting this should be easy by now, right? So this is 3 to the x equals 27 squared. But I need 27 to have a base of 3. So 27 is the same as what? 3 to the third. Now, pay attention. 27, we're replacing it with 3 to the third. So in parentheses, that's 3 to the third. Does everybody agree that this is the same as 27? And then we are squaring it. So when I have a power to a power, what do I do with the exponent? Multiply them. So this is actually the same as 3 to the what? 3 to the 6. So when you drop your bases, you get x equals 6. It has to be multiplication, guys, because this is the same as saying 3 to the third times 3 to the third, right? And if you're multiplying 3 to the third times 3 to the third, how many 3's do you have? 3 to the third times 3 to the third. How many 3's is that? 6 of them, right? 3 here and 3 here, so that's 6. Okay. Okay, last two. Number 11. Log base negative 27x, or of x, equals 1/3. Do you guys notice anything about this problem? The base is negative. Is that allowed? No, so don't even do it. Write yourself a little note that says, can't be negative. Okay. So what's the answer here? No solution. We don't even have to do it. We have a negative base, so we automatically know that it's not possible. Okay. Last one. Log base x of 27 equals 3/4. So this is x to the 3/4 equals 27. How do I get rid of that exponent so I have just an x? Reciprocal. What's the reciprocal of 3/4? 4/3. And the reason we do that is because my 4's will reduce and my 3's will reduce. So we're left with x to the positive 1. How can I rewrite 27 to the 4/3? What kind of root is it? A cube root of 27. What power am I raising it all to? The 4th power. Okay, what is the cube root of 27? 3. And what's 3 to the 4th, guys? 81. So that's solving. So you're going to have x in a whole bunch of different places, and you're going to have to use all the different kinds of solving exponents methods that we learned in the previous unit in order to solve them. Okay?